All right. Let us continue from where we ended. And I'm back. We ended on this question here. Let me check. Okay, so we ended on this question. This question is 13b. So we are given this diagram here. And this diagram seems not to be new because we have recently discussed about the theorem which is used to answer this type of question. That in this question, you can see that we are given a triangle. We are given a triangle somewhere here. And in this triangle, you can see that you have an exterior angle, right? You have an exterior angle. You have an angle formed outside. This angle here, exterior angle. Now, it was pointed out that an exterior angle of a triangle is equal to the sum of the other two interior opposite angles. So this was discussed in the video part 1. So the exterior angle equals to the sum of these two interior opposite angles. So equals to W plus 85 degrees. Now the exterior angle is given is 128. So 128 equals to W plus 85. Now 85 will be subtracted from 128. So it will be 128 degrees minus 85. This gives you W. Now 128 minus 85, this will be giving you 3. Somewhere around 43 degrees will be equal to the value of W. So W equals to 43 degrees. The reason being that exterior angle of a triangle is equal to the sum of two opposite interior angles. Okay, so that is what the theorem states. All right, so let us continue. We are done with that question. Let me see if we have another question on that page. We don't have. All right, so we have this question here. Almost some of the questions which are ongoing questions we have discussed earlier, but I don't mind doing repetitions, okay? ABC is an isosceles triangle. ABC is an isosceles triangle, meaning that these two base angles here are equal. Okay, so BCD is a straight line. BCD is a straight line, meaning that when you take this angle plus that angle, will be giving you 180. So suppose this angle is, say, X. So to be that X plus 118 degrees will be equal to 180. Angles on a straight line add up to 180 degrees. So X in that case will be equal to 180 degrees minus 180 18 degrees, and this will be giving you somewhere around 62. Somewhere around 62 degrees. Checking, this is 10, that is 7, 8. So the answer for this angle here will be 62 degrees. So this angle here is 62 degrees. Now, if this angle is 62 degrees, automatically even that angle will be 62 degrees because that is an isosceles triangle. Now keep going. In a triangle, angles inside a triangle add up to 180 degrees. So that is to say, this angle, which is 62 degrees, plus this angle, which is also 62 degrees, plus A, that will be giving you 180 degrees. Okay, I think that is clear. Now, how do we move on from here? 62 plus 62, that makes you 124 degrees, plus A equals 180 degrees. So to find the value of A, that will be subtracting 124 degrees from 180 degrees. This will be giving you somewhere around 56 degrees. See that? Checking, that is correct. So A will be equal to 56 degrees. So the value of A. Find the size of one interior angle of a regular 10-sided polygon. Okay, they are talking about finding the size of one interior angle of a regular 10-sided polygons. All right, so there's this formula which says sum of all interior angles, sum of all interior angles in any shape equals to number of sides of that shape minus 2 multiplied by 180 degrees. This is the formula. This is the formula for any shape. So for this 10-sided polygon, the sum of 10 interior angles, the sum of 10 interior angles, the sum of all 10 interior angles will be equal to the number of sides, which is 10, minus 2, multiplied by 180 degrees. So if you work out that, you'll end up getting 8 times 180 degrees. And this will give you somewhere around 0.64, somewhere around 1440 degrees. See that? So you can check my calculations. If they are correct, then we are good to continue. So that it would be 0.6414, so 1440. So this is the sum of all 10 interior angles. Now to find the size of one interior angle, so one interior angle, to find the size of one interior angle. So you write here one interior angle will be equal to this sum, which is 140 degrees, divided by 10, because they need only one. So 10 interior angles add up to 140. How about one? So you simply divide this sum by 10. So in that case, you'd be ending getting 144 degrees. That is your final answer. All right, I hope that is clear. Let's go to this question here. All right, so this question says, in this diagram we can see here, AG AG, where is G? All right, AG and AF are straight lines, okay? They're straight lines. Lines BC and DE are parallel, okay? They are parallel. All right, so if they are parallel, let us trace the shape, something like Z. For parallel lines, we prefer checking something like Z. Okay, we prefer checking something like Z. So this line here seems to be parallel. It seems to be parallel to this line here. It seemed to be parallel to this line here. So in that case, we are going to look for something like alternate interior angles. See that? That this line is parallel to that line. So in that case, this angle here, which is 28, will be equal to that angle there, which will also be 28 degrees. So if the question is find angle CAD, find angle CAD. So C is somewhere here. This is angle C. I mean, this is point C, and this is E, and this is D. So find the angle CAD. CED will be this angle. CED will be that angle, which is CED will be equal to 28 degrees. Because alternate angles are equal. So when you get a shape like Z, that means you'll be getting something we call alternate angles. So for alternate angles, look for a shape like Z. Now Z can be either something like that, but still Z is Z, provided that line and this line are parallel. This line and this line must be parallel. Same here. That is something like Z. I hope that is clear. Now let us try to move on with the next question. All right, so CED will be equal to 28 degrees. All right, now, another question is question number 15. But this question number 15 is on the topic of transformation. So we are done with graphs, we are done with angles, then we have moved on the page of transformation. Now, under transformation, we'll be talking about translation, we'll be talking about rotation, we'll be talking about translation, and also we'll be talking about refraction. So each category here has its own corresponding qualities. Now let us start with this question number 15. Look at the triangle. So this is the triangle we have. Now the question is translate. So we are talking about translation here. See that? Translation. So look at the triangle drawn on the grid. Translate this triangle 3 squares left, and 4 squares up. Okay, now how do we do translation? To translate a shape, we have few steps. To translate a shape, we have few steps. Now, step number 1 is to identify the vertices or the angles which make up the shape. We have to identify the vertices or the corners which make up the shape. In this case, we have 3 corners making up the shape. So we need to translate, we need to move. We need to move each point in a given distance or in a given direction. 3 squares left and 4 squares up. So let me start with this point here. This point here, I hope you can see my cursor. This point here has to move 3 squares left and 4 squares up. So from here, 3 squares left. 1, count the boxes. 2, 3 boxes or 3 squares left. And then go up 4 squares. So from here, 4 squares up. 1, 2, 3, 4. So the point is now somewhere here. All right, so let us talk about the other point, this point here. This point has to go the same movement of 3 squares left and 4 squares up. So 3 squares left, we have 1, 2, 3 squares left and 4 squares up. 1, 2, 3, 4. So the point will be there. How about this point? Same movement. 3 squares left, 1, 2, 3, 4 squares up, 1, 2, 3, 4. You see? Now I have moved the previous corners, and the previous corners have taken a new location. So what we do finally is you take a ruler, connect those vertices or these points to get a shape. The new shape you get is what we call the image. So this shape here is the image of this object, the image of that object. I hope that is clear. So translation in this case is at least done. Let us move on to the next question. The next question is number 16. This question says, shape A is drawn on a grid. You can see that this is shape A. This is shape A. Now rotate shape A 90 degrees clockwise about point C. So in that case, we'll be talking about rotation. So this part here, rotation. Now, in order for rotation to happen, in order for rotation of a shape to happen, we need to have few tools. In order for rotation to happen, we need to have few tools. Number 1, we need to have a tracing paper. We need to have a tracing paper. And number 2, we need to have somewhere around pen, and we need to have pencil. I will explain why we need a tracing paper, why do we need a pen, and why do we need a pencil. Now, under rotation, we need to know the center of rotation. Also, we need to know the angle of rotation. Also, we need to know the direction. Now, the direction can either be clockwise or anti-clockwise. So we need to know the direction where we'll be rotating the shape to. So under rotation, we need to know the center, we need to know the angle of rotation, we need to know the direction. So in this case, you can see that rotate shape A, this is shape A, rotate shape A, 90 degrees is your angle. So the angle of rotation, is given. So here, 90 degrees is your angle. So the angle of rotation is given. Also here, clockwise stands for direction. So the direction is given. The direction is given. About point C. Point C, which is here, is what we call the center. So you can see that in order for rotation to happen, three things are there. Angle is there, direction is there, also center is there. So what we need are the tools. We need a tracing paper, we need a pen, we need a pencil. All right, now let me try to get the tracing paper so that I can show you how do we do rotation. All right, just hold on. Okay, so here we go. All right, so you can see that my tracing paper is already. So this is my tracing paper. This is my tracing paper, and I'm going to show you how do we use this tracing paper. All right, so once you get a tracing paper, I hope you can see the tracing paper there. Once you get a tracing paper, then on a tracing paper, you see, I hope you can see that tracing paper. So once you get a tracing paper, then what you do next is to put the tracing paper over the diagram and make sure that the tracing paper is also covering the center of rotation. All right, so a few things you have to do after getting a tracing paper over the diagram. So the first thing you have to do is to trace the shape. Trace the shape using a pencil. Trace the shape using a pencil. Trace the shape that way. Trace the shape that way. You have to trace the shape in a way that you don't create the other different shape. So you trace the shape, then on this tracing paper also you have to mark where the center is. So in this case, the center is on point C. So you have to mark the center on point C. Few more things you have to do. Draw an arrow on a tracing paper. Draw an arrow on a tracing paper so that when the arrow is facing horizontally, that means you have moved the shape 90 degrees angle. If this arrow will point somewhere this way, when you'll be rotating, that means you have gone an angle of 90 degrees. When the same arrow points vertically down, that means you have gone an angle of 180 degrees, and so on and so forth. All right, so the last thing after getting the tracing paper, the last thing will be getting a pencil. It's done. Getting a pen. So you need to have a pen. And why do we need a pen? It is because we need to hold the tracing paper very strongly so that the tracing paper should not lose the center as we will be rotating. So we need a pen in such a way that we will be using this pen. To hold the center very strongly, so that when the tracing paper, as we rotate, when the tracing paper loses the center, then the pen will be there to remind us where the center of rotation is. Okay? So you need what we call a pen to hold the center of rotation. Okay? So once everything is in place, then we are good to rotate. We are good to rotate this shape. We are good to rotate that shape in a given direction. And the direction here is clockwise, 90 degrees, about point C, where C is the center of rotation. Okay, now let us try to start rotating the shape. Let us try to rotate the shape. The shape has to be rotated 90 degrees clockwise, about point C. Now, let us begin to rotate. How do I know that I have completed the 90 degrees turn? The 90 degrees turn is completed when this arrow will be pointing to the right-hand side. There will be your 90 degrees turn. All right, let us try to turn the shape clockwise, Can you notice that the center is going away from our pen? Can you see that? All right, so our arrow is now pointing to the right-hand side. That indicates that we have moved a 90 degrees angle. But then the center must be here at the tip of the pen. So you have to drag your tracing paper back to the center, and it should be looking that way. See that? So you have to adjust your tracing paper in such a way that it goes back to the center. See that? I hope that is clear. So there we go. Now, after doing that, we have to make sure that we locate the points where our new shape is. We have to locate where our new shape is. All right? Let us try to go more last time. You rotate that way. Okay, you rotate that way until that arrow becomes horizontal. There is your 90 degrees, and make sure that you go back to the center like that. You go back to the center like that. Okay? So far, so good. So, all right, so let us now take a pencil and try to highlight the new location of this shape. So the new location will be somewhere here, will be somewhere there, okay? I hope that is clear. Then you have to take out the tracing paper, leaving these points exposed, okay? Right, now you have to take your pencil, then connect this point from here to here, then that point to this point, for you to get the image of the object. That is your image, all right? So that is your image, and you have to label that this is the image of our shape, okay? So you have to label that this is A, and this will be A, but A dash, to mean that this was the object, and this is the image. So A dash means the image of A. I hope that is clear, and you can see that the way how the shape will look like. All right, so I may say rotation is done. I may say that rotation is done. So I'll be moving to another part. So rotation is done. Rotation is done. Then let us see if I'll have another question of either rotation or do the other questions, okay? So rotation is done. Then let us move on. Okay, this question says, describe fully the single transformation that maps triangle A onto triangle B. So triangle A onto triangle B, so that indicates triangle A is the object, onto triangle B is the image. That is what it indicates. So in this case, we are given the object and we are given the image, but we have to state what type of transformation is used to move triangle A onto triangle B. So we have to state whether this object here, triangle A, has been moved to triangle B. In this case, B is our image, has been moved by rotation or translation or enlargement or reflection. So we have to find out. But as how it can be seen here, clearly, this shows that shape A, which is the object, has been turned to triangle B, and turning means rotation. Turning means rotation. So the type of transformation which is moving triangle A onto triangle B is purely rotation. How did I know? You can see that the shape A has been turned around onto triangle B. So the type of transformation here is rotation. Now, if it is rotation, we have to state the center of rotation, we have to state the angle, and we have to state the direction, whether clockwise or anti-clockwise. Okay, so whether clock or anti-clockwise. So we have to specify this direction. Is it clockwise or anti-clockwise? Okay, so to do this, we need a tracing paper again. To do this, we need a tracing paper. So let me check if I can get a tracing paper. All right, so here we go. We need a tracing paper. Yes, that is my tracing paper. And we are going to use it to show how shape A was turned. We are going to show how shape A was turned onto B. Okay, so we need a tracing paper. The tracing paper is with me here. And then we need a pen. We need a pen to discover where the center is. So in this case, we are given the image and we are given the object. So we have to try the center. We have to try the center as well as the direction, right? So now let us try to trace the shape. trace the shape that way. Trace the shape that way. And then mark an arrow somewhere on a tracing paper. And then this time, let us try to guess that the center is somewhere here. Okay, now, guessing the center somewhere there. All right, so we have guessed that there is your center. We have guessed that the center is somewhere at 2, -1. Okay, is at 2, -1. There is your center. Now, let us try to see if this center will work. Let us try to see if that center will work. Now, how do we know that it has worked? The idea is, let us try to turn clockwise, because this shows that triangle A to be moved to triangle B, that is rotation clockwise. But then the center is guessed to be 2, -1. So put your pen somewhere there, so that when you lose the center while rotating, the pen could be able to remind you where the center is. Now, the idea is, let us try to turn that shape 90 degrees. There we go. Come back to the center. You find that this triangle on a tracing paper is not matching with triangle B. It's not matching with triangle B. They were supposed to match that way, you see? But unfortunately, they didn't match. So that indicates that our center is incorrect. Our center is incorrect. So we have to guess another center. We have to guess another center. Now this time, let me guess there. Let me guess there. 4, -1. Let me guess that center, that it is at 4, -1. So if the guess is correct, then I'm good to go. But if the guess is incorrect, I have to keep guessing until I get hang of it. Until I guess hang of it. All right, take the pen, mark the center there, and then turn clockwise, because it shows purely that the rotation was clockwise and 90 degrees. So keep going. Rotate that shape. There is your 90 degrees, but your center has lost. So you have to go back to the center there. There we go. Can you see that they have matched? Exactly, they have really matched. So that means our center is 4, -1, and our angle is 90 degrees. So here you write that our center is 4, -1, and the angle is 90 degrees. So here you simply write the rotation, the transformation which maps triangle A onto triangle B is purely rotation. Now, rotation of which angle? It is rotation of 90 degrees about 4, -1, and the direction is found to be clockwise. So you are done. So here, rotation, yes. Angle, yes. Center, yes. So that marks the end of that question. All right, let us continue. Let us continue and see what is happening here. Right, so we are good to go. All right, so let us continue. We are left with like somewhere around 20 minutes. Let us continue with some other questions. All right, so that part was done. So here we go. Describe fully the single transformation. This question was done. Let me check another question here. This question here. How many questions are left? Oh, wow. Only one question left. Right, thank you. So that is done. Rotation of 90 degrees about 4 clockwise. All right. So the last question is this question here. Question number 18. Now let me try to zoom out so that we can definitely see the question, the whole question. Okay. I tried to make it that way. So the question is, describe fully the single transformation that maps triangle T onto triangle P. Now, what does it mean? It means that triangle T onto triangle P, it means that triangle T is the object and triangle P is the image. That is what it means. See that? Triangle T onto triangle P. So we have to state the transformation. What type of transformation maps triangle T? What type of transformation maps triangle T onto triangle P? So triangle T is the object and triangle P is the image. So we have to state whether it is rotation or it is enlargement or it is refraction or it is translation and so forth and so on. But basically, when I check, when I look very closely, you find that triangle T onto triangle P, you find that triangle P, being the image, triangle P is a total refraction, of triangle T. Triangle P is a reflection, triangle P is a reflection of triangle T. Because the way how I can see triangle T to triangle P, I don't see a shape T being turned. So there is no point of rotation here. So what I can clearly see, I can say that triangle P is a reflection of triangle T. So now if it is a reflection, then I need to guess where. So here, number one, I can see that that is refraction. It seems that shape P, this shape here is a reflection of that shape. So if it is a reflection, I have to guess where the mirror line is. I have to guess where is the mirror line. So the mirror line which moves triangle T to triangle P should be the line that goes exactly in between of this space you see here. It should be a line that crosses this space here. If I say mirror line, I mean I should be able to guess the line that goes through this space. Let me try to shade the space I'm talking about. The space which I'm talking about is that space. So the mirror line should be a line that cuts this space, yellow space, into two equal parts. If shape P has to be the reflection of shape T, we need to find a line. We need to guess a line that divides this yellow space into two equal halves. So let me try drawing the line passing through this point. Can you see that that line is not cutting the yellow space into two equal halves? So I can't say that this will be the mirror line. And I cannot even say that will be the mirror line. The mirror line should be somewhere there. This is the point where the yellow space is cut into two equal parts. So the mirror line will be somewhere here. See that? The mirror line will be somewhere there. And if you can see this corner, for example, is how many boxes from the mirror line? 1, 2, 3. How about this corner here? This corner here is also 1, 2, 3. How about this corner here? This edge here is 1, 2, 3 boxes. How about this corner here? Is also 1, 2, 3. So you can see that my mirror line is guessed correctly. Now, just to write the mirror line is not enough. You have to state the value, or you have to state this number, which is cut by mirror line. And this number here belongs to y and not x. So the mirror line is simply the equation y equals to -1, you see? So here you say, the type of transformation which maps t onto p, is simply refraction in the line. It is refraction in the line y equals to -1. And y equals to -1 is what we call the mirror line. All right? So until next time, this is the end of this worksheet. This worksheet was worksheet number, let me check, worksheet number 2. So until next time, I may say that bye-bye for now, all right? And this marks the end of this worksheet, all right? So bye-bye for now.